In question 9, we've been given two functions, f of x and g of x, and we are asked to find f of g of x, the composite function. So remember, we're always going to start with the first function. So g of x here is x minus 1. And then if you have a look, our second function is f. So we want f of g of x. So essentially what that means is our first function is x minus 1. And this is then going to become our input in our second function. And that's what we can see here. We always take the closest function is one we start with. We take the output of that and input it into the second function. So here, because we're having a f of g of x, instead of x squared plus 4, it's going to be x minus 1 all squared plus 4. For part B, we are told that the vector 3, negative 1 translates the graph of f of g to the graph of h. So this is essentially what we've got in part A. So this is f of g, and this is just vector notation. This question doesn't really have anything to do with vectors per se. It's just a notation which we should recognise. 3 means it's going 3 to the right, and negative 1 means it's going 1 down. So if you can imagine, we should recognise this as it is here in vertex form. So all this means is that we have got a quadratic with the vertex here at 1, 4. So that's our function. We're then going to translate that using this vector. So we can see that we're going to shift it 3 places to the right. So if we shift this 3 places to the right, then this is going to become x minus 4 all squared. And if we shift this, the second part, down by 1, this is going to become x minus 4 squared plus 3. This is in vertex form. So now what we have to do is just interpret that in the context of the vertex form, which we can say the coordinates of the vertex is then going to be 4 and 3. So just remember that in general, if we have, for vertex form, if we have f of x equals x minus h squared plus k, then the vertex will be at hk. So the sign of the y-coordinate is the same. So if it's plus k, then the y-coordinate is k. But the sign of the x-coordinate is counterintuitive at first glance. So if you've got x minus h, then the x-coordinate is actually going to be positive h here. So in this instance, the coordinates of the vertex are 4, 3. Part C asks us to show that h of x is equal to x squared minus 8x plus 19. Now, if you've already, in the previous question, used vertex form to interpret the vertex, then all you've got to do here is just expand. So if we expand this, we're going to get x squared minus 8x plus 16 plus 3, which therefore simplifies to give us x squared minus 8x plus 19. In part D, we're told that the line y equals 2x minus 6 is a tangent to the graph of h at the point P, and we're asked to find the x-coordinate of P. So if this line is tangential, then there's going to be a point at which they have the same value. So in effect, here's our first equation, which is x squared minus 8x plus 19. Because it's tangential, that they must have a point in common, so we can say that there will be some point on this function which is the same as the point on this function. So we can set them equal to each other. We can rearrange that. That's going to give us x squared minus 10x plus 25, and we should recognize that that is going to, well, we can factorize that. That's going to be x minus 5 all squared, so that's going to be equal to 0. So we can solve that and therefore establish that p is going to equal 5.